Hello friends, how are you? Hope all of you are very well. Now, in this lectures of series, we are going to basically discuss the Junior Maths Olympiad for the level of class 5 and 6. So here, today I am going to start the number theory, but here in these lectures, we will not do any problems. This will be only the simple introduction of beautiful numbers. Okay now? So now let's begin our journey. First is, what is number? Suppose if I say 4 apples, 4 oranges, or 4 peoples, 4 math books, then you can understand what I am telling. So behind counting, the idea, that idea is nothing but the number. So a number is actually way of thinking, an idea that enable us to compare the very different sets of objects. Now 4 oranges and the 4 potatoes, they have one thing is common, their quantity is same, but the quality is different. One is the potatoes, one is the oranges. So it is an idea behind the act of counting. So number is actually the idea behind the act of counting. What is numerals then? Suppose if I say a number is 4, if the number is 4, then how can we denote this 4? We denote this 4 by this symbol. This is the numerals. Now we have tens numerals that are known as the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 to build the numerals. So these numerals, these digits is actually we use to form the numbers. If I say 25, so now 25 is 2, 5, 25. So 25 is a number but not the digit. It is a number, not a digit. Digits are only 0 to 9. These 10 digits we use to form the number, to form the numbers. So 25 is a number but not a digit. Hope all of you understand this concept. So it is just like our body is made up of cells. In the similar manner, every number we can form with the help of these digits. Okay now, so here the ideas, that is the number, numeral and digits, I think all of you understand this. Okay now coming to the next slide. Prime number, a natural number. All of you know about the natural number. Natural number is starting with 1, that is called the counting number. 1, 2, 3, in this way going on. A natural number is called a prime number if it has exactly 2 different positive factors. If I take the number 2, so now 2 has only 2 different positive factors, 1 and 2. If you take 3, the number 3 has 2 different positive factors. So these are 2 prime number. But if you take the another number 4, and you notice that it has more than 2 positive different factors, 1, 2 and 4. So that's why it is not a prime number. A prime number has only 2 different positive factors. Now if I ask you, what about this number 1? So you notice that 1, you cannot find 2 different positive factors of 1. That's why 1 we consider neither a prime number nor a composite number. So 1 is not a prime because it does not have 2 different positive factors. So what is the first prime then? The first prime is 2. The first prime in the set of prime number, if you denote by the capital letter P, then the first prime is 2, next 3, then 5, then 7. After that, first prime 2 digit is 11. then you go 13. In this way it's going on continue. So 2 is the first prime number. And one more thing, 2 is the only even prime. It is the only even prime. All the primes other than 2 are the odd numbers. You never find except 2 a prime number is even. Only 2 is the even prime. You notice that in the set 3, 3 is the second prime but first odd prime number. 3 is the first odd prime number. Is it clear? And we say that 1 is neither a prime nor composite. Now one question arises, the number of prime is finite or infinite? You have to think about it. Think about it. Number of primes. Number of primes is finite. That means there should be some end where this set we can count and say up to this number we have only prime numbers. The number of prime is finite or infinite. So think about these questions. Now prime is okay. Next is the composite number. A natural number is called a composite number if it has more than 2 different positive factors. So here I am discussing already about the number 4. It has 3 positive distinct factors, 1, 2, 4. If you take number 6, 6 has a factor 1, then 2, then 3 and 6 itself. So it has 4 different positive factors. So if any natural number has more than 2 different positive factors, then we call them a composite number. Is it clear? Now next is twin prime. If the difference of 2 prime number is 2, then they are called twin prime. So if you take this one 3 and 5, so you notice that their difference of these two, what is this? 5 minus 3, that is 2. If you take 5 and 7, then 7 minus 5 is 2. If you take 11 and 13, so now it will be 13 minus 11, again 2. So in this way, if you have 2 prime numbers and their difference is 2, then we call them twin prime. And in the number theory, only you find the 5 is a number which is common in 2 pairs of 2 twin prime. 5 is also present here. 5 is also present in this set. You never find such a number which is present in 2 pairs of prime. So 5 is a common prime number which is present in 2 different set of twin prime number. Now the question arises, which is unsolved in mathematics. Are there infinitely many primes? Unsolvable problems. Primes are infinitely many twin primes, not only primes, we are saying about the twin primes. This pair it has some ends. That means we count that and we say there are total 1000, 2000 or 2500 twin primes are present, not more than that. So these questions arises, are there infinitely many twin primes or finite twin primes? Unsolvable till now. If it is infinite, then you have to prove. If it is finite, then we have to prove it is a finite. Okay, now perfect number. Now perfect number is very interesting. A natural number which is equal to the sum of all its factors except itself. So now consider the number here is 6 or 28. You can take 6, you can also take. Now 6 has a factors 1, 2, 3 and the number 6 itself. So except that number itself, if you add all of them, 1 plus 2 plus 3, you get the number itself. Then this type of number is called perfect number. What about the number 4? 4 has a factor 1, 2 and 4. So except 4 you have 1 and 2. So 1 plus 2 is not equal to 4. So this number 4 is not a perfect number. 4 is not a perfect number. Don't confuse with perfect square. I am telling about perfect number. So now, dear students, try to find out the difference between perfect square and perfect number Okay, now 28 is also the same. It is the sum of its all factors except the 28 itself. So 28 is also the perfect number, second perfect number. Now the question arises, these types of number are finite or infinite? We have to find out. Okay, now so perfect number is okay. I hope all of you understand. Then go to the next slide. Amicable number. Amicable number is very special type of number. Once a person asked Ramanujan, one of the greatest mathematician, that why don't you have a friend? Then Ramanujan said about this amicable number. Okay, now so what is it? Now try to understand. Two number here, you notice that 220 and the number 284, they are amicable number. Why they are amicable number? Now 220 and 284, it has the factors 1, 2, 4, 5, 10, 11, 20, then 22, 44 and 55 and 110. Now if you add all these factors, 1 plus 2 plus 4 plus 5 plus 10 plus 11 plus 20 plus 22 plus 44 plus 55 and plus 110. That means except the number itself, if you add all its factor, you are getting a number, the sum is 284. And if you do the same things for 284, now 284 has the factors 1, 2, 4, 71, 142. So except the number itself, if you add all this number 1 plus 2 plus 4 plus 71 plus 142, so you are getting 220. So sum of all its factors except the number, you are getting another number. So if it is happened for the two number, one is called the amicable number of other. That means one person is present, then other is absent. Just the factors of all the factors, addition of all the factors except that number is the second one. So that's the Ramanujan give the answer that why did not he has any friends, because he follow the amicable number rules. When you add all its factors, then the second number will come. So that means if Ramanujan present, then his friends not present. Or if anyone who is friend of Ramanujan, then the friend present, then Ramanujan is absent. Like that he is convincing that person. So these are the amicable number. Now the question arises, how many amicable numbers are there in the number systems? Are they finite or infinite? So think about it, big questions. Amicable number are finite or infinite? Finite or infinite? Amicable number. Now next is Fibonacci numbers. Fibonacci numbers is what? This sequence, if you notice that So first term is 1, second term is also 1, and after that, after the second term, you notice that every term is just sum of the preceding two terms. Every term just the sum of the preceding two terms. It is n minus 1 and then n minus 2. Fn, if you take any number n, so it is fn minus 1 and then fn minus 2. Okay, now so here n, if you take here 3 1 2 3, that is n starting with 3. This is my f1, this is f2, this is f3. So Fibonacci number, it follows some recurrence relationship. So if you want to pick up, if you want to find any number in this sequence, you have to just add the previous two number. So 1 plus 1, next number is 2. 1 plus 2, next number is 3. 2 plus 3, next number is 5. Now 3 plus 5, next number is 8. Now 5 plus 8, next number is 13. 13 plus 8, next number is 21. Now next to 21, 21 plus 13. In this way you are getting. So sum of the two previous terms, when you add, you go to the next term. But you remember that here starting number f1 and f2. f1 is 1, first number is 1, and f2 is also 1. We see the application of these numbers or natures. In the natures, many things follow the Fibonacci sequences, like the petals of the flowers, reproduction in the rabbits. And this Fibonacci sequence is related to the golden ratio. Now in the next slide we will learn what is golden ratio. I hope all of you understand about the Fibonacci numbers. Since it is the beginning of the numbers and it is only for the students 5 and 6, so I am not discussing in the great details of everything of these Fibonacci numbers or the that we have discussed already before. I will make separate videos on these numbers, their properties, and how they follow the different types of identities. On these things I will make videos, and really all of you will enjoy it. I know my followers, my friends, my colleagues, my students, my children, they love the numbers, they love mathematics. Now the golden ratio, it has a huge applications. The golden ratio, anything in the natures, in the universe which is beautiful, they must follow the golden ratio. So what is it? If you have a two number, one is the bigger, other is the smaller, naturally not we are taking the same numbers. So here a greater than b. So now the ratio, if the ratio is same, is the first number is to second number is equal to the sum of the numbers and the bigger one, sum of the numbers and the bigger one. If any numbers follows this, that means I want to say if I called a by b, so this will be equal to a plus b by a. A should be the bigger one, and this is denoted generally by phi sign. Okay, now so it is defined by phi, and phi approximately, it is actually irrational number will come. When you solve it, you are getting one irrational number, phi square plus phi plus 1. So I'm not telling about that things because it is beyond our scope. So only the limited thing the student will learn from here, and then we'll go to the divisibility in the next video. So phi is approximately 1.6. 6 sixes will come. So 1.6 approximately this value of phi. Dear students, you can do an experiment at home. Just take your ATM card, your parents' ATM card, and don't use in the ATM. For the mathematical purpose, just take the length of this ATM card, okay, now, and breadth of this ATM card, and find its ratio, L into breadth. So length into is to breadth. When you find, you are getting the number, the value is closer to 1.6. So that is the reason why the ATM card is uh, most attractive. Because it is not fully the square and it is not any other rectangles. It's made in such a way so that it follows this ratio and it will be the attractive. Not in the sense because you have a large amount in your account. This is not the case. Because of mathematics. You know about the many person in the world, they are very attractive, their faces are very beautiful. This is only because of the reason of the golden ratio. Have you heard about the Tom Cruise, Hollywood actors, one of the most attractive person? So his face follows this rule. His eyes, nose. Okay, now if you put his eyes in this, if you put his eyes in this rectangle, it's exactly fit. That's why his eyes are looking beautiful. Anything which is beautiful in the world, they must follow the golden ratio. Golden ratio. And in the ancient period, the people build the very strong structures and very attractive structures. Okay, now in technology they are using the these golden ratio concepts. Okay, now going to the next slide. Lucas number. Lucas number having the same property as such as the same property means here the definition is same. Like if you say L1 is 2 and L2 is 1, then L3 is the sum of the previous one, 3. L4 you have to add L2 and L3. 2 1 L3 is what? 3. So that means you have 4. What we observe that only the difference in Fibonacci number, here F1 is 1 and F2 is also 1, but in Lucas number they are different, 1 and 2. Other definition is same. Any term is equal to the sum of the just preceding two term. It is very closely to the Fibonacci numbers, but they have the different properties. We don't discuss more about the Lucas number, only the introduction is here enough. Okay, now coming to the next. Palindrome number. It is just a number which is, if you reverse its digits or take the reflection along the vertical axis, you are getting the same number. So that are called the palindrome number. If I am taking here 1 and 1, so you notice that from the beginning, from the end, if you read, you are getting the same number, 22, 33, like that. Any number you are taking like that, 1, 2, 3, 4, then 3, 2, 1. It is the palindrome number. So here about this axis, vertical axis, if you take a reflection, you are getting the same number. So this is the image part. Okay, now so very beautiful numbers are in natures. So these are known as the palindromes numbers. Okay, now so now in the cases of words also, English word, we have the same type of things. Suppose we have the word level. If you read the word from the beginning and the end, you are getting the same word. Now the word katak, K-A-T-A-K, katak. If you read from here or from here, you have the same word, katak. Okay, now to like the palindrome number in English literature, we have the same kind of words. I don't know what is they are called. Okay, now but in mathematics, the numbers are known as the palindrome number. Hope all of you enjoy these numbers. Now next to it, Pythagorean triplet. No one in the world exists, they have the minimum knowledge and they never heard about the Pythagoras. So one of the greatest mathematician of all times. Now he has one beautiful theorem regarding the right angle triangle. Okay, now so what the theorem is, if the sides are denoted by ABC, then the theorem says that hypotenuse square is equal to sum of the base square and perpendicular square. So the number ABC will be any positive number, real number. But in case of Pythagorean triplet, this ABC has some restriction. They should be the natural number. So if any three natural number follows this Pythagoras equation, PE, Pythagoras equation, then we call them Pythagorean triplet. For example, here 3, 4, 5. So 5 square is 25, which is same as 9 plus 16. 16 means here you can take 4 square. So in this way you can define the Pythagorean triplet. Now the question arises, are they limited or unlimited Pythagorean triplet exist? You have to think about it. So think about it, they are limited or unlimited. That means I am asking about the question, they are finite or infinite. Can you prove, or it is still unsolvable in the mathematics? Okay. Now going to the last slide. Now it is a Ramanujan number. I love Ramanujan because he is my best. He is one of the best mathematician of all time, and he is my favorite one. You know about the story. You know about the story about this Ramanujan number also. Once his friend Professor G.H. Hardy had went to hospital to see the Ramanujan. In that time Ramanujan health was not good, and he was admitted in the hospital. So Hardy, when met him Ramanujan, he said that Ramanujan, today I come by a taxi which has a very peculiar number. The taxi number was 1729. Then Ramanujan said that the beauty of this number, this is the smallest number. Ramanujan said this is the smallest number which can be written as a sum of the two cubes in two different ways. So he said that you can write 1729 as 12 cube, which is 1728 plus 1 cube. Then you can write 1729 as 10 cube, 1000 plus 9 cube, that is 729. So now after that this number will be very popular in the theory of the mathematics. Everyone said this number is the Ramanujan numbers or Hardy Ramanujan number 1729. Okay, so this one is the smallest number. So now this is the story behind the numbers. So what we say, that our life is surrounded by the numbers. Whatever you knows about the other subjects, it does not matter, but you cannot free yourself from the numbers. From birth to end, your life is totally surrounded and confined. You are confined with the numbers. We cannot come out from these natures, from this boundedness of these numbers. So we all, knowing or unknowingly, using the numbers in our everyday life. So I hope all of you enjoy this class. Now we will meet in the next video. Till then, bye. Have a nice day.